thing, okay? Here's a globe, here's the Earth, okay? And right now, you guys are looking, here's the equator, here's the North Pole, here's the South Pole, okay? Now, last class we talked about great circles and small circles. So any circle that cuts the Earth exactly in half is a great circle. So the equator is 1, 2 equal halves. The prime meridian is 1, okay? 2 equal halves, okay? I could cut along the 90 west to all the way through 90 east, 2 equal halves. I could also do something screwy like this, okay? I could cut the Earth like this, whatever, doesn't matter. Okay, that's a great circle. But if I was to cut the top off this thing, okay? I would still have 2 parts. They would both have a circle, okay? But they wouldn't be the biggest circle. They would be small circles, all right? Now, here's an interesting thing, okay? Here's an interesting thing. A circle, a freaking circle. It's got 360 degrees, okay? I don't care what size it is, 360 degrees, okay? All right? Now, we can take that though, and we can say, in 1 degree, there are 60 minutes, okay? In 1 degree, there are 60 minutes, all right? So, I guess my question is how many minutes are there in a complete 360 degrees? So, 360 degrees times 60 minutes for every 1 degree. I made a conversion factor there. Degrees go away. So, what's 360 times 60 equal to?
$21,600.
Okay? There's 21,600 minutes in a circle. Okay? Everybody cool with that? All right, great. Well, why did I just do that? Well, number one, I wanted to torture you right off the bat, but this is also an interesting number. Why do we, we like these great circles for a number of reasons, but one of them is that a great circle, the equator, a meridian, they give us the Earth is the standard for the nautical mile. I don't know if you realize this. You go to France, and what's the standard for a meter? It's something like this. There's a freaking rod in a museum in Paris, which is the standard for the meter. Well, you know what the standard is for the nautical mile? It's the freaking Earth, okay? The standard for the nautical mile is the freaking Earth. Let me see you put that in a museum, okay? Anyway, so here's how it works. You take any great circle. Okay, now I'm lying to you just a little bit because we know the Earth is not a perfect sphere, but let's assume it was a perfect sphere. You take any great circle. 1 minute of arc on that great circle is 1 nautical mile. Okay? So, on a great circle, okay, 1 minute of arc equals 1 nautical mile. So, who can tell me? What is the circumference of the Earth? How many nautical miles is it around the Earth?
$21,600.
21,600. So you don't, somebody says to you, hey, what's the circumference of the Earth? You can say, well, it's 360 times 60, and then that's nautical miles because it's a freaking great circle. And 1 minute of arc on a great circle is 1 nautical mile. That's nice because the Earth is the standard for the nautical mile. Boom. Okay? Great. So, but now remember, these are nautical miles, not statute miles. Okay? Not statute miles, nautical miles. Okay, great. So we got that. All right? So what I want to do now is I just want to do a quick review of latitude and longitude. All right, so here we go. Here's the Earth. Okay, so what I'm going to do is I'm going to draw a circle up here that's looking at the Earth like this. Okay, so here we go. That's the equator. Okay, so you're basically looking at this. Okay, all right. Here's the equator. This is the North Pole. Okay. So we're going to be using this representation over and over and over again, right? So this is the South Pole. So P is pole, and then the letter denoting what it is. Q is the equator, all right? So latitude. Okay? North latitude. South latitude. Okay? South latitude. What's the latitude of the North Pole? Oh, it's 90 degrees. Okay, so this was like 15, 30, 45, 60, 75, 90. Okay, so from the equator up to here is 90 degrees. Okay, how about over here from the equator up to the pole? How many degrees? Oh, that's 90. From the equator down to the South Pole, how many degrees? Oh, that's 90. From the equator over to the pole this way, oh, that's 90. Oh, that makes sense. That makes sense. 9, 18, 27, 36, 360 degrees. Latitude makes 360 degrees. Okay? All right? Latitude encompasses 360, but we only think about it from 0 to 90, okay? 0 to 90, 0 to 90, 0 to 90, but it's really part of a circle. Okay? This is one representation of latitude. Latitude is an angle. Now, it doesn't seem so apparent that it's an angle here in this drawing. I mean, I guess you can see it here. But what if I was to do this? I'm going to draw this again a slightly different way. Here's the Earth. You know, here's the prime meridian right there. Okay? Here's the prime meridian right here. I'm going to get a machete. Whack! I'm going to cut the Earth in half. Prime meridian to the date line. I'm going to separate them. Now what we're going to do is we're going to look at that circle. Okay? So here's another look here. Okay? All right? This is the center of the Earth. And this is out here, this is like a great circle. Okay? This is like a meridian. Okay? And so here's the equator. So here, let's say this was, this is 0. 1, 2, 3, 4. Anyway, whatever. Let's say this was 30 north. I could represent that like this. Okay? Let's say this was 60 south. I could also represent that as this. Okay? Latitude is an angle. All right? It's an angle from the equator north or from the equator south. Okay? All right? It's an angle from the equator north or south. Cool. All right. We're going to use this picture over and over again today. This picture and this picture are related. This is the one we're going to use today, though. Okay? All right? So I'm going to be drawing, I'm going to be drawing this picture like this over and over and over again today. Okay? All right? And this will be like this, Q. And then we're going to use that. So these two are related, but that's the one we're going to use. All right, that's latitude. Okay?
Hey, Darren.
Yeah.
What's that word that you wrote in between Q and 30? Yeah, that one that starts with an M. Yeah.
Well, you can't read that? What's wrong with you? Where is that chicken that ran across the board?
Maybe I should get a magnifying glass and put it on the computer screen.
It was a bad piece of chalk, Rebecca. Bad piece of chalk. Terrible. Bad chalk. Okay,
Yeah, blame the chalk.
Sorry. This school's buying crap chalk for you guys. All right. So that is latitude. Now what we're going to do is we're going to look at longitude for a second. Okay. And this is all just a little bit of preamble. All right. Before we dive into it. Okay, so now we're going to talk about longitude for a second. Okay? All right, so here you go. Here's the Earth. And, okay, so here's Greenwich, England. Here's the prime meridian. Okay, so we're going to draw a circle again. We're going to start looking like this. Okay, we're going to look this way on. So I'm going to draw a circle. All right. And here's the equator. And here's the pole north. And here's the pole south. Okay. But instead of emphasizing east-west lines, now we're going to emphasize north-south lines. Okay. So we go like this. We say, hey, that's the prime meridian. So this is 0, this is 0. And then, we can draw the lines like this, right? At whatever interval we want. We say that this side is east. We say that this side is west. Okay? Great. Now, if this is 0, over here is 90 east. And over here is 90 west. Okay? All right? That's great. But when I draw it like this, I can only see half of the freaking planet. Right? Because there's a whole nother 180, 90, 90, that's 180. But there's a whole nother 180 on the dark side of the earth, as it were. Okay? There is no dark side. A little Pink Floyd reference for you there. Anyway, so what we're going to do is, when we're talking about longitude, we're not going to draw it from this perspective because it's kind of hard to see all the possibilities. So what we're going to do is, okay, so what did I just do here? Okay, so this is what we're looking at right now. Okay, North Pole, South Pole, here's the prime meridian, 0, right there. But what we're going to do now, look at me here. Okay, everybody take a look at me for a second because I'm going to do something and you need to kind of understand this whole thing. What I'm going to do is I'm going to take this Earth and I'm going to rotate so the North Pole rotates towards you. Okay? I'm about to draw this in a second. Here you are, you're looking at an equatorial view of the Earth. You're looking on the Earth from an equatorial view. Okay? You could say this is equatorial. You don't have to write that down, okay? But that's an equatorial view. What I'm going to do now is I'm going to draw it from a polar view. Okay, we'll draw it from a polar view. Now, all right, so you ready? Here we go. Hold on to your seats, okay, because I'm going to rotate the Earth and you might feel a jostle, okay? You ready? Here we go. I'm going to take the Earth and I'm going to rotate it 90 degrees in this orientation. So now what's in the center is the North Pole, okay? So here you go. I'm going to draw this circle, okay, and here is the North Pole, all right? That's the North Pole. Olivia, what's this circle right here? All the way around here. What's this thing? That's going to be the equator. Okay? That's going to be the equator. Don't worry about that so much. We don't care. Where did the prime meridian go? If I rotated it this way, where did the prime meridian go? It went right here. 0. I could also label that Greenwich if I wanted. I could also label that prime meridian if I wanted, okay? I'm not going to label it with those letters. I'm going to put 0, okay? Cool. All right. Well, if that's 0, what's up here? That's 180. Okay? All right? That's the date line. Okay? This is the prime meridian. Okay? Cool. All right. Now, this is useful for us. This is useful for us. Everything on this side is now west. And everything on this side is east. Okay? All right? So I can go like this. This would be 90 west. This would be 90 east. Okay? 90 west, 90 east. All right? Cool. Great. And here's 180. 180 west, and it's also 180 east. It's both of those, okay? 180 west, 180 east. Ah, that's weird. Okay. All right. I'm going to pause for just a second, and then I'm going to. Everybody caught up? All right. Now, watch. I want you all to look up here. Don't draw anything. Look up here for a second. Here's the prime meridian. We're looking equatorial view. Here's the prime meridian. What direction is that? Look, here's Maine. Here's California. That's west. That's west. Okay. When we go this direction, it's west. Okay. Now, everybody watching? Everybody watching? Clockwise is west. Clockwise is west. So in this perspective, if I go this direction, I'm going west. Okay? All right? Oh, cool. All right. Yeah, here we go. Equatorial view. That's east, east, east. Ready? Going this direction, counterclockwise, that is east. Okay? This notation is very important. If I go, when I'm looking at a polar view, okay, and Greenwich is down at the bottom, clockwise is west, counterclockwise is east. That's how I'm going to be drawing longitude today, okay? So, here's a question for you. Sam,
Hi,
which direction am I going?
you're going west.
Okay, great. All right, great. Love it, love it. Tyler, Patrick, which direction am I going?
East.
East. Okay, now I'm going east, I'm going east, I'm going east. I crossed the date line. What direction am I going?
East.
I'm still going, I'm in the Western Hemisphere, but I'm still going east. Okay? Oh, shit. Okay, cool. All right, here we go. Here we go. I'm going west. I'm going west. Now I'm in the Eastern Hemisphere. I'm still going west. Okay. All right? Okay. All right. Let me look at my notes. All right, cool. So today, we're going to be using two circles, one for latitude and one for longitude. All right? All right. So, all right. So what we're doing here is we're getting ourselves set up to do what's called the sailings, okay? Another bad piece of chalk, Rebecca. Oh God.
I'm pretty sure we're paying a lot for that chalk.
Yeah. That must have been the chalk that was one chalk makes them smaller and one chalk makes them. These are Alice, anyway. Okay, so go ask Alice. Yeah, anyway, okay, all right. I'm not condoning drug use, by the way, it's just I remember that song. All right, so sailings. Sailings are calculating course and distance. Okay, calculating course and distance, or lat and longitude of arrival using math instead of a chart. Okay? The sailings are calculating course and distance, or the latitude and longitude of arrival, the latitude and longitude of where you're going, using math instead of using a chart. Okay? So we're gonna, and I gotta tell you something, you know, a couple hundred years ago, people were doing a lot of navigating by math. Okay? All right, so we gotta do a couple of definitions. All right? Let me just show you kind of a little example of what I'm talking about. We're on the Earth. Okay? This is the equator, pole north. This is an equatorial view. Let's say I start a voyage right here. Okay? So, point of departure. Okay, the point of departure, that's where a voyage begins. Okay? That point of departure has a latitude, okay? The abbreviation for latitude is going to be L, okay? The abbreviation for latitude is going to be L. Well, that point also has a longitude. The abbreviation for that is going to be the lambda symbol, okay? The upside down Y. Why? Because, okay? So, this spot has a latitude and a longitude, all right? Now, and then let's say we want to go to this spot, okay? This is spot 1. This is where we want to end up. So, point of arrival. Well, doesn't that have a latitude and a longitude too? Okay? This has a latitude and a longitude as well. Okay? Cool. Well, we better differentiate between these two because, like, I got latitude. Which one are you talking about? Well, this is L1 lambda 1. This is L2 lambda 2. Okay? All right? Cool. All right? So, I could say, using the sailing, I could say, what is the course and distance between the point of departure and the point of arrival? Okay? And we can do that by math. That's one thing we can do. We're going to do that next week. Another thing I could do is I could say, hey, you know what? If I start here and I go this course and distance, what will be the coordinates of the point of arrival? So that's two things we'll do. We'll come back to that next week, okay? But first thing is these little L's here, okay? Great. Now, here's an interesting thing. Okay? Let's take a look at this. When I went from here to here, I changed my latitude, right? Let's say this was 10, let's say L1 is 10 north, okay? And over here, L2 is 50 north. I changed my latitude by 40 degrees. That's called little L, okay? So here's another definition. Little L is the difference between L1 and L2. Okay? So, difference. You know, I didn't. Okay. Let me write the words out. Okay. Difference in latitude. That's the term. It is abbreviated by this italics lowercase l, and it's the difference between L1 and L2. Okay? All right, cool. We're going to do some calculation of that in just a minute. All right. Hey, cool. So, little l is how the latitude changed. Put it into layperson's terms. Okay? How the latitude changed. That's called little l. Now, hey, freaking look at this, people. Our longitude changed as well. Did our longitude not change? Yes, it did. Okay? Our longitude changed as well. There's two different ways we can write that. So difference in longitude. Okay? New term, difference in longitude. All right? So, this can be represented by this. Difference in the longitude symbol. Okay? You might see me use this. Or, this is another way you can do it. Difference, these both are difference in longitude. D low, okay? When I say this in English, I'll just say D low. But you know, so these two are synonymous. These two mean the same thing. D lambda and D low are the same thing, okay? And what are they? They are the difference between longitude 1 and longitude 2. Okay? All right? So, we're going to be teasing that out today. There's one more thing we're going to look at today, and that's called the mid-latitude. The mid-latitude. Okay? The mid-latitude. Mid-latitude. That's abbreviated capital L lower m. Latitude mid. You know, see over here? We had latitude sub 1. Latitude sub 2. Well, this is latitude sub m, mid. Okay? And what's that? Okay? It's halfway. It's halfway between L1 and L2. Okay? It's halfway between L1 and L2. If I wanted to write a formula for that, if I wanted to write a formula for that, it would be this. Well, anyway, I'm not going to write a formula for that. No. But I'm going to show you where that is. You ready? Here's latitude 1. Here's latitude 2. Huh. Right there. That's your mid-latitude. Halfway between them, okay? And we're going to be calculating that today as well. All right. I'm just writing little notes over there on the side for my timing. All right, I'm going to give you a little breather here for a second while can I erase?
I don't know, can you?
Oh!
Adam,
Oh, that's how it is, huh?
good one, Rebecca.
Oh, I still got the bad chalk. I still got the bad chalk. Okay, you ready? Okay. What the frick, Tyler around? What the hell are you laughing at? What, did I do this?
Just previous jokes. But yeah, it was funny. I don't know.
Oh, you guys are private chatting, huh?
No,
Oh,
no,
frickin'
no, sir.
Tyler Hall is laughing his ass off over there too. You guys are freaking private chatting.
No, sir.
I can put a stop to that shit. Just so you know, I got a little feature. I can say no chat. All right.
We were
Don't
just
make me
text.
pull this Zoom over. Don't make me. Okay, so for latitude, we're going to do an equatorial view. Q. Okay, I'm always going to draw it this way: North Pole up, equator along the middle. For latitude, okay? Cool. All right. Let's say I want to, so we are calculating the difference in latitude, little l. All right, you ready? Okay, here you go. Let's say we start off here at L1, 28 north, okay? All right, L1 is 28 north. And we go to L2, 14 north, okay? So we started off at 28 north and we went to 14 north, okay? Now, we're interested in two different things here, okay? We're interested in two different things here. We're interested in the number of little l. We're also interested in the sign of a little l. What direction did we go? Okay, so Justin, okay? Here we go. I started at L1 and I went to L2. So that is little l. Justin, what's the direction of little l? Is it north or south?
It is south.
Yes. So even though I'm in the northern hemisphere, the direction of little l is south. Okay? South. Cool. All right. Now, what am I going to do with that? Okay? What am I going to do with that? Well, I need to do the math now. Okay? So how am I going to do the math? Am I going to add those or subtract them?
Subtract.
Andrew,
Subtract.
you with your freaking camera off. What do you think? Andrew? Somebody better text Andrew and tell him he's about to get a 0 for a 10. Ah, there he is.
I was
Well, how am
printing
I
out
gonna do math? Am I going to add those or subtract them?
for what?
Oh, somebody wasn't freaking paying attention, huh? Chuck.
I was trying to print out the worksheet so I could do them.
Well, trying to go that way with me, huh? Okay. Chuck, what am I going to do here? Am I going to add these or subtract them to get the difference in latitude? Oh, and somebody else wasn't freaking paying attention either. Okay. All right. So I'm going from here to
Oh,
there.
sorry. I didn't unmute myself.
So that is 14 south. I went 14 degrees to the south. Cool. All right, let's do another one. Okay. Andrew. All right. We're going to start with L1 is going to be we'll start L1 is going to be 11 south. Okay? L1 is 11 south. Okay? Andrew. And Andrew, we're going to go to 38 north. Okay? So we're going from 11 south to 38 north. Andrew, what's the direction of that? Is that north or south?
For the midpoint, you'd be moving north.
Okay, so we're moving north. So the direction of that is going to be north. And what am I going to do with these? Over here, I subtracted. What am I going to do with them over here?
You're going to add them.
I'm going to add them. Okay, so that's 49. All right, cool. All right, this is what I want you to do now. All right, I want you to do a few problems on the worksheet. All right, so I want you to go to the worksheet. All right, and we're going to do problems 1, 4, and 5. Okay, we're going to do problem. I'm going to do problem 1 with you. All right. Now, by the way, I don't have like a giant freaking calculator here that you can see, so I'm going to do these problems using just hand arithmetic. But if you want to use your calculator for these, even on the test, you're welcome to. And there's going to be, there's already a video that kind of shows how to do it using a scientific calculator. Okay. But so you need to download that worksheet. Okay. And I'm going to do problem 1 over here. Okay, because this one's going to involve some little incrementy stuff. All right, so we're on page 1 of the handouts. The handouts are numbered. Down at the very bottom are the numbers. So we're on page 1, D lat Okay, so here's your picture. All right, and we're starting at L1. L1, according to it, is 437 south. L1, okay? All right? That's L1. All right? What's L2? It's 353.6 north. That's L2. Okay, so L2. All right, so little L is that. All right, so I'm going to put 353.6 here. Okay, north. Okay, now I need to get the number and I need to get the sign. Okay, I need to get the number and I need to get the sign. So, Dylan, what's the sign? Am I going north or south?
North.
North. Great. Now, what am I going to do? Am I going to add or subtract?
Gonna add.
I'm going to add. Okay. So now, when you're adding, you can add these 2 up by your calculator. If you don't know how to use the fancy thing that you can watch the video for, but you can just add these up 2 by your calculator, and you'll get 90.9. When you add these 2 up, you get 7. Great. What's the problem with 90.9?
Doesn't exist. You gotta carry it. Take 60 out, carry it over.
Well, it does exist, but usually we don't let this number get above 60. We don't really let it get above 59.9. So we're going to take 60 out, and then that 60 will come over here. It'll make this 1. So it'll 1. So that's 8, 30.9 north. That is little L. Okay? All right, so now what I want you guys to do is take a minute and do number 4 and number 5. Okay? Actually, let's just do number 4. You guys can do number 5 later, okay? So take a crack at doing number 4 now. So hopefully you're coming up with a number of 3 degrees, 20.4 minutes, okay? All right, 3 degrees, 20.4 minutes. But if you didn't get that, it's okay. I'm gonna just show you, all right? So look, first up, looking at this. L1 is here and L2 is there. So we're going south, first of all, okay? So, but if I write L1 at the top and L2 at the bottom, L2 is bigger than L1. And that's not how we normally do addition and subtraction. Normally, we put the big one up at the top and the small one down at the bottom. So although in this picture, L1 is on top and L2 is on the bottom, I'm always, when I do the arithmetic, I'm always going to put the big one on the top. So this is going to be rewritten as L2, 41, 41.7, L1, 38, 21.3, okay? And when I do that math, I should get 20.4, and I should get 3, and that is going to the south. All right? Okay. So we've been at it now for just about 46 minutes. So what I want to do is I want to just take a very short break. I mean short, like, like think about it like 3 minutes. Go to the head, do, 60 seconds jumping jacks, okay, whatever you want to do. All right, get a drink, okay. All right, take a minute because we're going to go through a whole nother hour in just a second. Well, in just about 3 minutes, okay. What we did there was difference of latitude, okay? Now what we're going to do is we're going to do difference of longitude. Difference of longitude, okay? All right. Okay. So remember that I can abbreviate that as D, okay, or, okay, D lambda, difference in longitude, D low, or D low. When I say this, I'm going to say D low, okay? It's just one less letter, though. All right. That's the down low on the D low, okay? And I just sent a tweet out to J Lo so that she would be in the know. Now we go. Okay, sorry about that. Oh, yeah, okay. Yeah, I know. All right. So we need a different view for this now. Okay, so now we're going to use a polar view, remember? Okay, we're going to use a polar view. That's the North Pole. Okay, that's the North Pole. Got it? So, but I'm not going to draw that in. I'm just going to draw a line like this. And I'm going to put 0 here. Okay? So really, that should be pole north. That should be 180. But probably what I'm going to do is I'm just going to put the 0 there. And it's understood that that's the freaking North Pole. And that's freaking 180. Okay? I'll draw it in for now. But I'm not going to draw it in again. All right? So, let's see here. Rebecca, what direction is that? Clockwise.
West.
West, yep. And Oscar, what direction is this? That was west, so this is east. Okay, great. All right, so you ready? Let's do this thing. Let's do this thing. We start at 87 east. We start at, so what we did previously was we broke up, we just did change in latitude. Now we're just doing change in longitude. Next week, we're going to put them together, okay? So, but anyway, okay, so here we are. We start at 87 east. So I should draw that like this. This is longitude 1, 87 east. Everybody got that? All right, now I'm going to travel from 87 east to 57 east. I'm going to go from 87 east to 57 east. Well, 57 east is going to be somewhere down about like this. So you got to be able to draw this picture. So what represents the change in longitude here? It's this. This is d lambda, okay? D lambda, right? D lambda right there. So here's the question for you. Olivia, if I went from longitude 1 to longitude 2, what direction did I go, east or west? I'm in the eastern hemisphere. I'm going to stay in the eastern, but I'm going this direction. What direction is that?
You're going west.
I'm going west because I'm going clockwise. Ah-ha-ha. So the sign of this, the directional sign is going to be west. Cool. All right. Love it. All right. Now, what am I going to do mathematically for this? How am I going to figure this out?
Subtract it.
I'm going to subtract. And when I do that, I get 30. Okay? So the change in longitude was 30 degrees towards the west. Good. All right. Let's do this. You're going to start at we're going to start at 15 east. 15 east. Longitude 1 is 15 east. Okay? Good. All right. We're going to 15 west. All right. So Tyler Hall, TH, yo, TH. What direction am I going? I'm going from here to there. Am I going west or east?
Going west.
I'm going west. So this is great. Okay. Now, what mathematical operation am I going to do here? Who wants to take a crack at that? Am I going to add these or subtract these?
You're gonna subtract.
Well,
You're gonna
hey,
add.
check this out. How many degrees is it from here to here?
15.
And how many degrees is it from here to here?
15.
It's another 50. Shit, that's two 15s. What am I going to do with those?
Add them.
I'm going to add them, okay? Yeah, it's tricky, okay? So when I was on the same side, when I had the same signs, I subtracted. But when I go opposite signs, I'm doing a little add thing here. That's interesting. Okay, so that's 30. There are rules here that you can kind of follow, but I don't use the rules. I use the picture, okay? All right, we're going to do one more, and then we'll go to the worksheet. This one, okay? This one is some serious business right here. All right. We're going to start at 163 west. 163 west. So that's 180. So 163 should be, I don't know, just something like this. Okay? All right. Now, where are we going? Where are we going with this? Where are we going with this? We're going to go to 128 east. 128 east. So that should be something like this. my question is, what is the change in longitude? What is the change in longitude? All right. What is the change in longitude? Changes in latitude, changes in attitude. Okay. Did you know that, yeah, he was singing about D lat. Yeah, anyway, yeah. All right. So, Chuck, if you're going to go from here to there, are you going to go in this direction, you think? Or are you going to go in this direction? You're going to go in direction 1 or direction 2 based on what I just drew? Direction 1 or direction 2? You're thinking about your fuel economy, by the way. Which way are you going to go?
2.
What's that?
2.
You're going to go 2, okay? If you're going to go 2, you could go this way, but you're going to go that way because it's the freaking shorter way. So let's get rid of this. Our change in longitude, okay, is going to be from there to there. We're going to cross the date line. So Chuck, how are you going to do this? How are you going to do this?
Subtract the 163 from the 128.
Okay. All right.
Right.
Well, go ahead and do that. Do 163 minus 128 and tell me what you get. Just bang it out.
35 degrees.
35. Okay. So, 128. What is 128 to 180? Well, 180 minus 128, that's 32. Okay? So from here, that's 32 degrees. We've almost used up all of your numbers so far. And then from here to there, that's another 17 degrees. 180 minus 163, that's 17. So the whole thing is 32 plus 17, that's 9. That's 49 degrees. Okay? So that was a great hypothesis, but it didn't work.
Captain Tarrant,
Yeah.
wouldn't that be 52?
Oh, don't go confusing the story with the facts, okay? All right?
Confusing me.
It's that damn, oh, I got that same damn piece of chalk.
The cheap
Yeah.
shot.
Here. See, that's what a math teacher will do for you. The value is X. Ha! Take that, smart ass. All right. I don't know what the freaking number is, but whatever the freaking number is, Chuck, you had a great idea, but it didn't pan out. So what are we going to do with this? We
Add them.
could do what I just did there, but that's a pain in the butt. Olivia, you got an idea?
You could That add was them. me.
What's that?
That was me. I said add them.
Ah, okay. All right, so let's add them. Let's go 163 and 128. What do we get when we add them? Don't even think that I'm going to do the math for you guys because I would want to embarrass myself again. Actually,
291.
It's 291. It's 291. Is that 291 degrees? No. But you know what is 291 degrees? This plus this. That is 291 degrees. If I add those two, I get 291. Well, what do I do if I want to get this one now?
Subtract that number from 360.
Exactly. So I'm going to go 360 minus 291, and I get 69. Okay? which means my original math over there was way the F off. All right? Anyway, okay? That's how you do that. When you cross the date line, what you're going to do is you're going to take that and that, add them together, and then subtract it from 360 to get the internal angle. Otherwise, you have to do 180 minus 163 and 180 minus 128. You got to do that math correctly, and then you have to add those two. Okay? Questions? All right. Smart asses. Oh, did I say that one? All right, so what we're going to do now is we're going to go back to the worksheet. And I want you to do a couple of ones from the worksheet. I'm going to choose probably 2. And then we're going to take another topic. We got a couple more topics to go. Here, Rebecca, just for you. I might as well break this already because it's going to break anyway. I don't know my own previous journey. What?
It's gonna solve all the problems.
Yeah, all the problems, all the problems. All right, so we're on page 2. All right, page 2. All right, so page 1, page 2, it says find the difference of longitude and label it east or west. All right, and the first, so page 2, I want you to do problems 1, 2, and 4. All right, and I'm just going to draw the picture so you know that you're on the right page. Your longitude 1 is 12.2.7 west, and longitude 2 is 009 3.2 east. Okay, that's the page I want you to be on. And go ahead and do 1, 2, and 4, and I'm going to put them up on the board. Actually, do 1 and 4. No, do 1, 2, and 4. We'll do 1, 2, and 4. All right, I'm going to do number 1. All right, and if you had any trouble with number 1, you're going to see me do it right now. Longitude 1 was 12 west. Longitude 2 is 9 east, so I cross over the prime meridian. I'm going this way. That means I'm going to the east. And now I just do a little bit of math. Oh, that's a pain in the ass. If you're using a calculator, it's no problem. But I can borrow 1 from there. That becomes, well, anyway, you just do it by the calculator, whatever. That's 2105.9. Okay, that's that one. But if I was, I guess to do that, it would be 11. Did I do that now? I'm going to do 3.7, 10.
If you're adding them, you wouldn't have to borrow.
Oh, you know what? I'm all screwed up here. I just went on autopilot there. Sorry. This is 1202.7 west and 903.2 east. All right, yeah. So I wasn't even thinking. I was on to the next problem. All right, so I went there. I went 12 degrees to here, and then I went another 9 degrees to there. So I got to add these two. All right, and that makes 2105.9, and I went east. All right, there, that's better. I got a little kerfuffled. This one here, so I crossed and I added. All right, this one here, I'm going to stay on the same side. 10. By the way, notice, I'm not really stressing out about, like, that's more like 50 degrees. I'm not stressing out about that. I'm just going to draw these relative to each other into the prime meridian. So I know that 10 is going to be farther out. I'm giving myself a little room to work. Okay, I'm not worried about getting the angles exactly right. I'm trying to get the relationship right. So I'm going from 7, okay, so I'm going from here to there. All right, so my change in longitude 1 oh, there we go. Okay. Longitude 1 is 7. And longitude 2 is around 10. Okay? So what direction am I going? Am I going east or west here?
West.
West.
Going west. All right? I can see there's it's the same error as last time. Now, am I going to add or subtract them?
Subtract.
Subtract, yep. So that becomes 3, 2.8. All right. This last one here, you should end up with, what'd you guys get for this? Did anybody get, what'd you get?
3 degrees, 20.4 minutes south.
What's that? So this last one is going to end up being 533.4. So 177 west, that's where we're starting. And we're going to 177.13 east. We're going that way. Okay, so what direction is that, first of all? Is that west or east?
You're heading east.
Well, so I'm going into the eastern hemisphere, but I am going west to do it. This is tricky, okay? This is tricky. I'm in the western hemisphere, I end up in the east, but I went clockwise, so I am going westerly to do this. That's tricky. All right, now how am I going to do this? I can do 180 minus 173.13.3, and 180 minus that. I can do that twice. Or I can take this angle and this angle, and I can add them up and subtract them from 360. So that's what we're going to do. I crossed the date line, so I'm going to add these two. When I add them, you should get 354. 26.6. When you add those two, you should get 354, 26.6. And then I'm going to do 360 minus that. All right, so I'm going to go 360 minus 354, 26.6. Now, if you watch the video, if you don't know how to do this like really easily on your calculator using, degrees and minutes, you might, right now I'm going to do it by hand, okay? But you can do this on your calculator without actually having to do it with your pencil. So here's what I'm going to do. I can't take 26 from that, so I'm going to borrow one from here. That's going to be 359. And if I take one from there, that's going to be 60. But I need a 0 here. I mean, I got a 0, I got to take a 6. So now I got to borrow one from the 60. That'll give me 59, and I get 10/10. So here's a little point. 360 equals 359, 59, and 10/10. So that's what I'm going to do here. I'm going to take 354.26, and I'm going to subtract it from 359, 59, 10. And now I can do that fairly easily just by hand. 6 from 10 is 4, 6 from 9 is 3, 2 from 5 is 3, 4 from 9 is 5, 0, 0. And I went west.
Can you explain that again, please?
Which part? Which part, Tyler?
That whole thing.
Like why did I add these two together?
No, like the borrowing thing.
Yeah, I'm gonna do that one more time. All right? I'm gonna do that one more time.
Captain, I got the same thing, but I think I had like an easier way to do it.
Oh, what's that?
So I just subtracted one side from 180, and since it's the same number, I just doubled it. And then
Oh, and that worked, but usually it won't be exactly the same number.
Well,
So-
can't you subtract each side from 180 then?
Yeah, Oscar, you absolutely can. You absolutely can do that. And I actually did that when I did the first example and I did the math wrong. But absolutely, Oscar, if you want to do it that way, if that's how your brain works, you should do it that way. Absolutely. No problem. Two different ways. You can subtract both from 180 and then add them, or you can add them and subtract them from 360. You'll get to the same number. All right. 360. All right. 360. Another way that I could write that is 360 degrees. If I took 1 degree from that, I would have 359 degrees. Okay? If I took 1 degree, so this is 360, no minutes and tenths of minutes. If I took 1 degree from that, I would have 359.60. Okay? 359.60 and 360 are the same thing. But what if I wanted to have, now I'm going to subtract 354, 26.6. Well, I still have a problem because I can't subtract 6 from 0. So now I'm just going to do regular borrowing. Okay, I'm going to do regular borrowing as normal. So this becomes 59, and this becomes 1. But the 1, there's already a 0 there, so that becomes 10. That becomes 10. So 360 equals 359, 59, and I put it up high, okay? I put it up high so that you know that you'll be able to subtract the 6 right from it. All right? If anybody has any more questions about that, I'd be happy to entertain those on a one-to-one.
Captain Tarrant.
Yeah.
Back to like problem number 1, you cross the date line going east, so you don't have to do anything like with the 360 there, only if you're going west over low 180.
Yeah, you don't have to do that 360 thing unless when you cross the date line, you're either going to have to subtract them both from 180 and then add them up, or add them and subtract them from 360. But when you cross the prime meridian, you don't have to do that.
Okay, thanks.
All right? Okay. All right, we are now starting another idea related to these things. Okay, before, we're going back to latitude now. We're returning to latitude, right? This is the latitude. Okay, and now what we're going to do is calculate L2. Calculate L2 if you're given. That means if you know L1 and L. Okay, calculate L2 given L1 and L. That's what we're going to do now for the next few minutes. All right, you ready? Example 1. L1 is 9 north. L1 is 9 north. All right? Now, what we're going to do is, L1 is 9 north. What we're going to do is we're going to go north. Little L is change in latitude. We're going to go north 11 degrees. So we're starting off at 9 north, and we're going 11 degrees to the north. So now we need to name the latitude. All right, so now if I'm going 11 degrees to the north, what is L2? What is L2? So what's the sign of L2 here? Pat. I went from 9 degrees north. I'm going further north 11 degrees. Am I going to be in the northern or southern hemisphere?
Northern.
Okay, so now what we're trying to do is name the latitude, not the direction of motion. All right, so, all right, well, if I'm at 9 north and I go 11 degrees further north, what order of operation am I going to do here? Am I going to add or subtract these?
Add.
I'm going to add them. And so what is latitude 2? That's
20.
going to be 20 north. All right? Let's do another one. This one, L1 is going to be 3 degrees south. Okay? And I'm going to go to, I'm going to go south 47 degrees. I'm going south 47 degrees. So the question is, what's L2? What's L2? Rebecca, if I start at 3 south and I go another 47 degrees south, what's the latitude? What's the sign of the latitude going to be? Am I going to be north or south at the end?
South.
South, perfect. What am I going to do with these two numbers? Am I going to add them, subtract them? What am I going to do with them?
I'm going to add them.
I'm going to add them. Okay. So there you go. So that becomes 50 south. Great. All right. Great. Let's do one more, and then we'll do some problems. And then we'll do some problems from the worksheet. There you are. Let's say you start at 48 south. All right, and you're going to go. 50. No, actually, let's not do that. You're at 48 south, you're gonna go, little L is 11 north, okay? Little L is 11 north. All right, you're starting at 48 south and we're gonna go to the north. So, what's L2? So first up, Tyler M. Am I still gonna be in the southern hemisphere or am I gonna be in the northern hemisphere? If I'm at 48 south, I go 11 degrees to the north.
You're still gonna be in the southern, right?
Yes, I'm still gonna be in the southern. All right, great. Now, how am I gonna do this? Am I gonna add these two or subtract them?
Subtract.
Now I'm gonna subtract. So that's gonna be 37. All right. So let's do this. I'd like you to now go back to your handout packet, and I'd like you to go to worksheet 3, okay? And I'd like you to do problem page 3. Do problem 1. And problem 2. Okay, do number 1 and 2. All right? So go to the worksheet, go to page 3, do problem 1 and 2, and while you're getting a jump start on that, I'll start setting those up on the board here. All right. Here we go. So, what do we do here? This one's a little bit different. What'd you guys get for this? The answer for this one should be 319.4 north. All right? So, how did I get that?
Subtracted.
Yes. All right, so look, I'm starting here. I took, what I want is, this is what I'm looking for. From the equator to L2. What was I given? I was given this, and I was given this. Okay, so this is the latitude 1. This is the change in latitude. I was given this and this, and what I want is that. So if I take this, I subtract this. If I take little l, I subtract latitude, what's left will be L2. So I take the big one here, which was L 10, 6.6 north, and I take my smaller one to put it at the bottom so my subtraction goes nice, 647.2, that was south. but I know my direction is north. So I know that I'm going to end up in the northern hemisphere, right? I'm going to end up in the northern hemisphere, so this becomes north. And if I do some subtraction, when I do that, I'll get 03 19.4. And here I'd have to do a little borrowing. I could do, this would be 9, and this becomes 76.6, at which point I can just do my subtraction, all right? So that was that. Number 2, I'm starting off at 3847.6 south. And I'm going to go north 8 degrees and a little bit of change. So what's L2? All right, well, I'm still in the southern hemisphere, so it's going to be named south. And here, I'm going to take that. All right, I'm going to take the full latitude. I'm going to subtract a little L, and I'll get L2. So I'm going to subtract this one, and that is 809.6. And I should end up with 38.0. All right. All right, we got 2 more things to do. Let's take, we have till 9:55, so we got about 24 minutes. So let's take literally just go get it, 2 minutes, okay? Just, all right? Get a drink, use the head, whatever it is. Just take a little break here. I'm going to be quiet for a couple minutes myself. I got to fill my water as well. I'll be back in 2 minutes. All right. So I want to cover 2 more topics fairly quickly. All right. So what I'm going to do this time is what I've been doing is I've been doing easier problems for the examples where we're whole degrees. And then we've been jumping to the worksheet. But what I want to do now is I just want to just jump to the worksheet and we'll just do the problems with the minutes in there. All right. In the interest of time here. So we are now going to go directly to page 4 in your handouts. Go to page 4, and we're going to start with problem 1. We're going to start with problem 1. So this is a longitude problem again. Find longitude 2 given longitude, that wasn't longitude 1 and change in longitude. Find longitude 2. I had a little mistake up there. Given longitude 1 and change in longitude. So we are now back to the polar view. Okay, North Pole. Right? We're back to the polar view. Because we're doing longitude. All right. Now, in this problem, longitude 1 is 3.4 east. Okay, that's okay. So I'm going to draw that on my globe. Longitude 1 is, oh, what the, no. Yeah, that was right. Oh, is 3.4 east. So, here we are. This is longitude 1. Oh, I got this wrong in the key, damn. 3.4 east. Great. Now, what direction am I going?
West.
Okay, so I'm going to go west. Now, how far west am I going to go?
Your DLO.
Okay, and that is how many degrees?
10 degrees, 46.1 minutes.
Okay, so if this is 4 degrees and I'm going to go 10 degrees, I'm going to cross the prime meridian, right? So I'm going to end up over here somewhere, right? Longitude 2. So the question is, what is longitude 2? Starting off here at 4 east, but I'm going to go, so I'm going to the west. Remember, this is east, this is west. So I'm going in this direction, and I'm going to go in that direction 1046.1. So the question is, what's that new longitude? How am I going to do that?
Add them.
Well, what I know is I know this angle. This angle is 1046. What else do I know? I know this angle. That angle is 3.4. What do I want to know? I want to know what this angle is right here. So I got a big one, I got a smaller one.
So you subtract.
I'm going to subtract. So what I'm going to do is now, when I subtract, I put the bigger number at the top. I put the smaller number at the bottom. So which of these two is the bigger number? 1046.1 or 3.4?
10 degrees.
Okay, so you're going to put the 10, so you're going to put the D longitude at the top, and on your worksheet, you'll see it's already at the top. So the worksheet, it's setting you up for the math. So the D longitude is 1046.1, and the longitude 1 is 3.4. Okay, we're going to the west, this was east. And now I got to do a little bit of math. When I do the math, I should get 642.7. 642.7. Now, what am I looking for? I'm looking for longitude 2. I'm looking for longitude 2. All right, longitude 2. So, Andrew, if I'm looking for longitude 2, I got to put a name here. So, am I going to put the name of the direction that I traveled, or am I going to put the name of the hemisphere that I'm in? Okay, if I'm looking to label longitude 2, am I going to put the direction of the travel, or am I going to put the name of the hemisphere?
You're gonna put the name of the hemisphere you're gonna be in.
Now, in this case, they both would have been west, but if I had been going east, I still would have labeled it west. All right, so anyway, that was number 1. Let's do number 4.
My internet
Number
cut
4
out.
together.
So what was that?
We're going to do number 4 together.
No, the hemisphere or the what you labeled.
It'll come up in an example. But let's say I had started here and I went this way, I'd be going east. But if I only went a few degrees, I'd be going east, but I'm still in the Western Hemisphere. So I would still, all right, so you gotta remember what kind of thing you're doing. Are you talking about the direction of travel, or are you talking about the name of the coordinate?
Thank
All
you.
right, let's do number 4. In number 4, we're going to start off at 134 east. 134 east. So that's 90 east. So that should be something about like this. That should be something like this. This is longitude 1. Now, what is my change in longitude for this problem? All right, so longitude 1 is 134.04.9 east. Okay, what is my change in longitude? It's 26.2. Okay, it's 26.2. Now here's where it gets screwy. It's 26.2 in which direction?
West.
West. All right. So if it's west, should I go this way? Should I go this way, direction 1, or should I go this way, direction 2?
Direction 2.
Should I go this, direction 1, or this, direction 2? Yes, 2. Right? Even though I'm in the Eastern Hemisphere, remember, always clockwise is west. So what I'm doing now is I'm going to go west. How much am I going to go west? I'm going to go west 26.2. So that means that this is going to be longitude 2. So I started at 134, 6.9, and I'm going to go 20 degrees west. What is longitude 2? So 26.2 west. What am I going to do with these two numbers to get this guy?
You're going to subtract them?
I'm going to subtract them. All right? So this is really, I've been drawing a picture every time, and I think you guys should be drawing pictures every time as well. All right? So there you go. So that's 26.2. And so when you do the math there, you'll end up with 113.58.7 east. All right. So we did 2 examples of that. Now we're going to do the last topic for today. Calculating the mid-latitude. Right? Calculating the mid-latitude. All right. Calculate the mid-latitude, which is abbreviated capital L, little m. All right, let's say we start off L1, 10 south. All right, L1 is 10 south. And L2 is 24 south. L1 is 10 south, L2 is 24 south. And I said to you, well, where is LM? LM would be halfway between them. Be halfway between them. All right? So if this is 10 south, that's 24 south. LM is smack dab in the middle. Smack dab in the middle. So, if I have 10 south and 24 south, what am I going to do with these two numbers to get the middle latitude?
You're going to add them together, then divide by 2.
Okay, so what do you get that? Take 10 and 20, so that's 34. So you went 10 and that, so you added them, you got, so add, and you got 10, 24, you got 34. Then you divide it by 2. All right? And what'd you get? 17. Great. That's exactly how you do it. Right? Is there another way we could have done it?
Do you have to convert minutes and seconds or just use degrees for those first two locations?
Where are you talking about?
I'm talking about when you're finding the mid-latitude, are you just using the degrees?
No. I just started with an easy problem here. Okay.
Oh, okay.
I just started with it. Yeah. It's a new concept, so I just dropped all that stuff. We're going to be throwing that degrees and minutes in there in a second. All right. Let's do this. What's another way I could have done this?
Taking the difference and then added it 10.
This is method 1. Here's method 2. Okay? There's method 2. You ready? So in method 1, we added, and then we divided by 2. In method 2, we're going to calculate little l, and then we're going to apply it to L. How do we do that? All right, well, little l is the difference between these two. Little l is the difference between these two. So 24 south and 10 south is 14, okay? So little l is 14 degrees. Little l is 14 degrees. That was step 1, calculate little l. What is, excuse me. Apply half of little l. So here, check this out. That's little l. This is half of little l. That's little l between L1 and L2. And from here to the midpoint, that's half of little l. Well, hell, here's the other half of little l. So what is half of little l? If l is 14, half of little l is 7. Okay? So really, let's go back to these instructions here. Go back to this. Method 2. Calculate, instead of it being little l, calculate half of little l. Add that little half in there. That's important. And then step 2 is apply half of little l to L1 or L2. So it's 7. What was my original L1? It was 10. So L1 was 10. And little l is 7 south, that's 17 south. And that's the same number. Okay? Same number. 2 different ways of doing it. All right. So we got 5 more minutes. Let's just do, why don't you take a crack at page 5. Let's do number 1. And let's do number 5, and that'll take us out. All right? Do number 1 and do number 5 on page 5. All right, so for number one, I was 49.13, so I'm gonna be halfway between them. Okay, so I know that I'm gonna be in the northern hemisphere, but if I add them, I get 62.25. Now, okay, add them. And now I'm gonna divide by 2. So 62 degrees, 25.0 divided by 2, all right? Well, half of 62 is 31, and half of 25 is, what is that, 12.5? So that's 12.5, but that I'm going to convert that 0.5 to minutes. So that becomes 31, 12, 12 point, yeah. 31, what the hell am I doing here?
31 and 12.5.
12.5, yeah, 31, 12.5 minutes, and that is north. All right, that's that one. All right. So that was number one. Class is basically over now. All right, we got 1 minute left. There's not enough time to do that next problem without going over. So this is what we're gonna do. Since I put number 5 up there, I'm going to do number 5. If anybody wants to stick around, you're not required to stick around. The can't answer key to all this stuff is posted already. I realize that there's 2 errors in there, which I'm going to go back and fix, and then I'm going to post it again. So I'll post this key again by the end of the day. All right, that was a lot. I'm trying to figure out the pacing of this class as well. As it was described to me is, we talk about it for an hour and then you do worksheets, but today we did the whole time. I'm hoping that the next class, I'm only one class ahead of you guys. So the next class I'll be working on over the weekend, and hopefully that'll be a little bit more where I'll just, kind of do some examples in the beginning hour, and then you'll work independently, and I'll just answer questions in the second hour. I think that's the general norm for this class, though it didn't happen today. Cool. All right. Well, thank you for attending today. Anybody that wants to stick around, I'm going to do number 5. Otherwise, the answer to number 5 should be, if you want to just sign off here, the answer is 25.32.9 south. That's the answer to number 5. All right. So if you got to go into another class, great. Otherwise, anybody that wants to, you're not required to stick around. And if you leave now, I won't think anything badly about you. I just had too much, or I got another class, or whatever. So sign off. But I'm just going to give you a little extra something. So those of you, what I'm going to do is since I put the answer up there, I'm going to give you another 60. I'll give you another 1 minute. I'll give you another 1 minute to see if you can come up with that answer. And if you haven't come up with that answer, then I will do it. So we're going to start down here. Let's say L1, and we're going to go further south. Holy crap! We're going to go down like this. Oh, yeah, this is a weird one. All right, so there's 2 ways I can do this. And now so this one I didn't do an example like this. That's why I put this on here. Okay, so what we're looking for here is LM. All right, but in order to get LM, we're going to have a little pit stop in L2. Do we? Well, wait a minute. Method 2 was 1, calculate L, half L. And then step 2 was apply half L to L1 or L2. Right? So we can certainly calculate L2 and then add those two and divide by half. But LM is going to, if I went from here to there, that's all of L. If I just go halfway of L, I'm going to be at LM. So that's what I'm going to do. I'm going to calculate half of L. So what is L? It's 1427.4. Right? 1427.4. So let me just erase this because I need a little bit more board. Half of L equals 1427.4. All right, well, 14, okay, 14 is going to become 7. And what's 27.4 divided by 2?
13.7.
Okay, so that becomes 13.7. So half L is 13.7. So that means that what I got to do is I got to go 13.7 from L1. What am I going to do? How am I going to apply this to L1? Am I going to add it or subtract it?
Adding.
I'm going to add it. So now I'm going to go plus L1. L1 was 25. Excuse me. Well, that's the answer. L1 was 18. 19.2. So now I'm going to add those up. Okay? 7 and 2 is 9. 9 and 3 is 12. 2, 1, that's 3. 8 and 7, oh God. 18 and 7, that's 25.
Do you mind doing it the other way? Because I got a different answer.
No, I don't mind. I don't mind doing it the other way. Not at all. Okay. I'm going to do it the other way now. Unfortunately, my worksheet for the other way are down in the basement. So let me just go down and get those. Just a second. I'll be back in a second. Okay. All right. Great. I got it. All right. I'm going to do this. That was method 2. I'm going to do it again by method 1. So, method 1 is add L1 and L2, and then divide by 2. All right, well, I don't have L2 in this problem, so I have an additional little thing. I got to do an additional thing here, which is calculate L2. So this is an additional thing I'm going to have to do. So let's calculate L2. So L1 is 1819.2 and little l is 1427.4. So what's L2? It should be 3236.6. All right. Cool. L2 is 3236.6. So now what I'm going to do is I'm going to add up. Oh, let's do an experiment. I'm going to use yellow chalk and tell me if you care if I use yellow or white. Doesn't really matter. Okay. Now I'm going to add these two. So L1 is 1819.2. L2 is 3236.6. So I'm going to add those two puppies. And when I do that, I should get 5105.8. All right? 5105.8. So this is, now, depending on how you do this, this might be a little bit screwy. Okay? There's a couple different ways to do this. All right? So, well, what's half of 51? And what's half of this? Oh, God. Okay? I think if you want to do this, what's easiest to do is to if I was to do this in my head, not the calculator, okay? If I was to do this in my head, what I would do is I would make this an even number. I'd make that 50. What would I do with that 1? I'd apply it over there. What does that become? I'm going to add 1 to 5.8. I got to add 60. Now it's easy for me to do the division in my head. What's half of 50? 25. What's half of 60.8? 30.4. Oh, something's weird. Is that what you got?
No, I got 2527.9 for that.
Yeah, I think there's just small little arithmetic errors in here somewhere. And there might have been a little small arithmetic error over there. I thought the answer is 32.9. I did some kind of little small arithmetic error in here somewhere.
Well, I did too then, because
Well, I got the same thing as you, Patrick, when I did it this way, but I got the 30 or 32.9 when I did it the first method.
Huh. So, all right, I'll take a little look at that. Both of those ways should work just fine. I'll have to take a little ponder on that. Wonder if I did a little math. I wonder if there's a little, let me do this, let me do all the little math again, I guess. There's gotta be some little arithmetic error in here somewhere. Let's see. There it is. That should be 46, right? There's my arithmetic error right there.
yep, I can see that now.
That's the error. All right, so I pooched it right there. So that's great. I'm glad you brought that up and asked me to do that again because I pooched the key there too. So this is number 5. Arithmetic error. Okay, great. I think now if we do that, everything should be copacetic. So let's do 18. So now I'm going to do 18, 19.2. That's 8. 9 and 6 is 15. 5, 1. That's 6. 8 and 2 is 10. 0, 1. 40. 50. 50. Half of 50 is 25, and half of 65.8 should be what's 65.8 divided by 2? 30,
I think
2 and
it's
a
like-
half, 2.9.
Yeah. 32.
32? 32.9? Yeah, 32.9? Anyway, whatever. This should be the same answer. Yes, 32.9.
It's
All
been
right.
a long class.
Woo!
Yeah.
So what you're saying
Yes,
is method 2 is definitely the superior way to do this kind of problem.
absolutely.
Okay, because I had zero problem with method 2 doing this, but method 1, I was just like,
Yeah, method 1 was, method 1 is a pain in the ass. And I think actually what's going to be happening is that in your future, you're going to do more of method 2, less of method 1. All right? All right, peace out, people.
Thank you, Captain Taryn. Appreciate
All right,
it.
later, dudes.
See you later.